Okay. So going back. So which part here do you want us to focus more, or do you want us to do everything? All right. Let's begin. So, what I'd like you to do first is to understand the situation for you to know what to do. Okay. And this is 27 marks. So if you can do all these within 1 hour, then you will get a six if all are correct. If not, the other points will be derived from question number one. Okay, which we will also do today. So I'd like you to read the this statement first so that you would know what to do. All right. Let's start with before we begin. By the way, sorry. If you try to look at it, we are actually given a situation we're in. We are given a some sort of a location composed of different towns. There are actually four towns here. So the metropolitan area in a country is made up of four different towns. We have town E, F, G, and town H. All right, and you're given here the coordinates. So for the first question A, you are asked of how or why do you think that this model is reasonable? So why do you think that this model is reasonable enough? This one is open to a lot of possible answers, but you have to think of a reasonable answer. So why do we only represent each town with a point? That's the meaning of this question. Why not draw the entire town? Why a point? So anybody who would like to give his or her idea on this? What do you think happens if we draw the entire town? Anyone? By the way, any of you can answer. You can just join using the other. Yeah, we have now Javita, we have Phoebe, and we have Samantha. So anyone, any three of you, why do you think it's reasonable enough to represent them with a point? Why not draw the entire town? Just to check, can you still hear me? It's okay. It's okay. Okay, I'll give you time to read on this. We're still starting with the second question, so I'll give you time to read on this one, and then we are still doing part A. Just to guide you through, do you know the shape of the town? In this case, the square is actually the area itself, composed of four different towns. So town A is town E. F, G, and H are actually representing the vertices of the square, for example. But the shape of each town, the town itself, do we know the shape of the town? So if you try to look at to read this problem, the shape of the town is actually not mentioned. So we cannot assume the shape of the town to be a regular shape. It may not be perfectly um, the basic shapes that we know. It cannot be a triangle, it cannot be a square nor a circle. So the best thing to represent the town is by looking into the middle or the center of the town. And the center of the town can be represented in the Cartesian plane in a form of a point. So the reason why it's reasonable enough to represent each town by a single point, it's because we can just focus on the center of each town, and that center of each town, we plot it as a point. All right? That could be one possible reason, and there could be many other reasons for that. But I believe that that is the one that is usually done when we are plotting the location of let's say a certain place. So if you try to look at Google Map, for example, if you wanted to find, let's say, a certain place in the map, usually the point corresponding to that place is the center of that location. Okay, so that is actually how it is being estimated in the Google Map. The same thing is what's being done here. Okay, so these points represent the center of each town, and it estimates the location of the town in the Cartesian plane. All right. Now, this time I will share with you the um, I'll share with you the Jamboard for this, the Jamboard link. I'll send it um, in our group chat. So what I'd like you to do is first I'd like you to plot. I'd like you to draw or sketch a Voronoi diagram showing the regions of the metropolitan area that are closest to each town. In other words, using these points, draw a Voronoi diagram. And what I'd like you to do is to take a screenshot of it and send it in the Jamboard. All right, so that we can have a discussion. So I would know where to come in. So I'll send you the Jamboard link. This is the Jamboard link for the current problem that we're having. And I'd like you to write it in this slide, the second slide. Let me put in the problem here. All right. Okay, this one. So again, I'd like you to do letter B, draw the Voronoi diagram, and then I'd like you to paste it here. All right. You don't have to get it correctly, yeah? Just for me to check how you can draw the Voronoi diagram given the location of the 4 points. You may now proceed. Remember that to create a Voronoi diagram, you need to connect the 2 points, and then you need to create the perpendicular bisector. Okay? Kenneth and Joel, can you see me? Or sorry, can you hear me rather? Yeah, thank you, Kenneth. So for the two of you, I ask your classmates to draw a Voronoi diagram out from the given information. So if you have done this already ahead of time, since I have given you this already, you can take a screenshot of it and paste it here in the slide, second slide, which is shown in my screen. Okay. Anyone who would like to share, please paste it here in the screen. Please try. I'm still waiting for you to post your answers. By the way, why are you not posting? What happened? Is it difficult to do this? Oh, this just yeah. Thank you. You can now do it, so you can now paste your work. Sorry for that. Thank you so much. Okay. Who gave this answer? Sorry. Okay, it's Sam, right? Yeah. So, for the others, do you have any question regarding how Sam made her answer for B? Or do we have a common understanding? So if you have any doubts on this, then you can address it now before we proceed to the next. Everyone agrees? Please respond so that we would know if we are to proceed to the next or not. Yeah. So I think letter B is actually simple. All you have to do is to create a Voronoi diagram, and we know very well that since this is a square, so this must be perfectly vertical, this side here. This must be perfectly vertical. Therefore, the perpendicular bisector will just be a horizontal line, this one. And since it's a bisector, it must be in the middle. Okay? Now, my suggestion is you can use dotted lines for this to signify that those are the perpendicular bisectors. Okay? And I think this one is pretty understandable. So let's now proceed to letter C. So what are we trying to find out in letter C? So if we try to look at it, we are given here. Okay, let me just copy this one. Let's try to do this one by one. So for letter C here, you're actually given. By the way, you can open the one that I sent yesterday if in case this is not clear enough. So we are given here that there is another town, which is town I, located at a certain point. So perhaps we can estimate that town I is located somewhere to the right of 20 because it's 30, so it must be half of 30, 20 and 40. But then it is still having a y coordinate of 20. That means somehow it's found here. Okay? This is now your town I. All right? So, first, you are given that the equation of the perpendicular bisector of IE is this one. Take note that this is the perpendicular bisector of IE. So if we connect I and E, let's use another color here. If we try to connect this one here, okay, say this one, for example, the perpendicular bisector. So if we try to divide this into two, let's say roughly, just roughly this one, okay, that's the perpendicular bisector. It is being said that this has an equation of y equal to 3 halves x plus 15 over 2. All right, before I proceed, any questions? Okay, now what we are supposed to do here is to find the equation of the perpendicular bisector of IF. Okay, so let's try to see where IF is. F, I think this is, sorry, I think there's something wrong here, Sam, a little bit. This is not H, this is actually F. That is point F. Okay, so this one is not H. So you are to find the perpendicular bisector, the equation of the perpendicular bisector of IF. So if you try to connect IF here, okay, so IF would be this one, all right, and we just need to find the equation of the perpendicular bisector of IF. So we're looking for this, something this one, okay. So there in your notes, I'd like you to find the equation of this particular line, the perpendicular bisector of IF. I'd like you to work this out in your notes, and let's try to see which part here that you might need some help. But before you do that, let's identify the things that we need to do in order to find the equation of the perpendicular bisector of IF. So if you try to look at it, if you're familiar with Voronoi diagrams, we will make use of this equation y minus y sub 1. This is actually what we call as the point slope form, equal to m times x minus x sub 1. All right? So if this is what we're going to use, question is, what are the things that we need to know in order to find the equation for the perpendicular bisector? Can you give me one thing that we need to know here? Very good. We need to know the gradient. Question is, the gradient of the what? Very good. We need to find the m of the perpendicular bisector. Okay? Not the gradient of IF, but the gradient of the perpendicular bisector. And since it's a perpendicular bisector, so this line here, this one, must be perpendicular to IF. Is there a way? Do we know a way to find its gradient if we have IF? Can we find this m here? Or is the information enough? Yeah, this information is enough. Okay? Clue, we need to get the negative reciprocal. So, we now know how to get the m. What else do we need to know? Midpoint. Why do we need to know the midpoint? Why the midpoint? Why not this? Let me encircle it using yellow line. Why not the coordinate of I or the coordinate of F? Why the midpoint? Okay, let me guide you through again. If you try to look at the equation, I'd like you to focus on this equation here, the point slope form. All right? In order to find the equation of the line, we need the gradient, and we also need, what is this y sub 1 and x sub 1? What is that representing? We need a what? Anyone? By the way, I cannot tell you everything. I need to guide you through on how to analyze this so that later when the same problem is given, at least you understand how we were able to use these values or why we have chosen to find this point instead of the other points. So going back, gradient is correct. We need a gradient. Take note, the gradient of the perpendicular bisector, not the gradient of IF. Okay, that's clear. How about x sub 1 and y sub 1? What is it? What is that point referring to? Are we looking for a point found on IF? Is it a point found on IF? Because if it is, then we can use this coordinate here, and we could also use this coordinate here, this point here, the coordinates of these points, if it's found on IF. Again, take two. What we wanted to find is the equation of the perpendicular bisector, meaning this line here, the equation of this line. So first up, to find the equation of this line, we have to find its gradient, which is possible to find. Okay, check. But the gradient is not enough. We also need other information. And we know that we need to find x sub 1 and y sub 1. The question is, what is x sub 1 and y sub 1? What is that point referring to? Aside from, yeah, it's the midpoint, correct. But before we say midpoint, this x sub 1 and y sub 1 is referring to a point found on the point on the what? Point on the point on the perpendicular bisector. So whenever you have a line, let me just explain a little bit. In linear algebra, for example, please refer to the one on top. If I have a line here, for example, if you can see the red line there, for me to find the equation of this line, I need the slope, m of this line, and I need to have 1 point found on this line. So if I have both information, it should be any point. It could be this point, this point, this point, or any point, any of these four points. If I know the coordinates of any of those points plus the slope of the line, then I can use this one to find its equation. Do you follow? Were you able to get it? Please answer honestly so that I can elaborate if in case it's not clear enough. So is it clear that those two are needed to find the equation of the line? Yeah. Again, the slope of the line we're looking into and a point found on the same line. In other words, we have to focus on the perpendicular bisector. This one, focus on this. We need to find the slope of this, which is possible, all right, by referring to the slope of IF. And we have to find a point found on this line. It should be a point lying on this line. So if you try to look at it, it's difficult to find a point on this line other than this point here. Because this one, the intersection between the green and the blue one, who is note taker? Can you tell me who this one is? Note taker? Ah, okay, no problem. So again, take two. To find that point found on the perpendicular bisector, if you try to look at it, the only point existing is the intersection point between um, the green and the blue one. This point here. This point also is found on the perpendicular bisector. Do you follow? And what is this point? This point is the midpoint because this is a perpendicular bisector. Therefore, this must be the midpoint of this line here. That's the reason why we're using the midpoint. But the midpoint is not the primary reason why, or it's not the primary reason for this. The primary reason is we need to find a point found on the perpendicular bisector, and that point happens to be the midpoint of the green one. So you need to understand those concepts so that even if the situation has been changed, you could still solve it or work it out. All right. So are these things clear now? We have the gradient and the point on the line, which is the midpoint. So this time, since you know already what to find, I'd like you to work out the midpoint, work out the slope of the perpendicular bisector, and send or work out the equation of the perpendicular bisector and send it here in the same slide. All right, I'll give you some time to work it out. Okay, so we now have one answer here. Okay, yeah, you can just put it. Let me just arrange it here. Sorry, you can. I don't know why it's moving, class. Okay, let me just erase my writing so that this will be a little tidier. Okay. Okay. So let's try to have this answer here. Okay. I'd like you to examine the solution provided and try to ask questions if you have. You don't have to have the same solution. You don't have to provide the same lengthy solution. Or maybe if your solution is longer than this, it's still okay, no problem. For as long as there's no mathematical law that has been violated. All right? Okay. This time, any questions? Yeah, so this one is clear already. And can we move on to the next? Yeah. So again, just to discuss it quickly, we have the midpoint, which is the point we need, point found on the perpendicular bisector. I'm sorry, I have already erased it here. And then we found the median, sorry, the gradient of IF. Okay, but then we need to find the negative reciprocal. All right. So once we found the negative reciprocal, that is what we can use in order to, let's say, find the equation of IE. Find the equation of IF rather. All right. So the equation of IF would now be negative 1 half x plus 47.5. And so we have this already. So if we don't have any questions, then we can proceed already to the next task. Okay. So the next two tasks is actually asking you this one. Let me just take a screenshot of this. Okay. This one, these are the next two tasks. You're given the coordinates of one vertex of the new Voronoi diagram. So this is one of the vertices. This is not the location of the town, but rather the vertex of the Voronoi diagram. So if you try to recall, these are the vertices of the Voronoi diagram. When we create the Voronoi diagram out from this, we can actually see here a vertex of the Voronoi diagram, which is the one in the middle. All right. However, with the addition of another town, the town I, this will not anymore be the Voronoi diagram. Okay, so we expect to have I found here. Let me just again draw it. So we expect to have I found here. This is your I. And because of this, the Voronoi diagram would now change. It would not be as simple as this. So according to part number 2, given that one of the vertex of the Voronoi diagram is this, find the coordinates of the other two vertices in the metropolitan area. In number 3, you are asked to sketch the Voronoi diagram. If you try to look at it, it's difficult to visualize the other two vertices unless you see the Voronoi diagram. So even if this comes last, my suggestion is for you to do this first, the part 3. And then once we have done part 3, then we can find already where this is located, and we could also find out the other two vertices. All right? So I'd like you to draw the new Voronoi diagram given or including point I. All right? Can you do this now? Draw a new Voronoi diagram considering five different towns, E, H, G, F, and I. So just to give you a clue, you don't have to draw it accurately. So what you can do is just connect the two towns, and after you've connected the two towns, then you can somehow estimate the perpendicular bisector. Let's say this one, okay? And then do the same thing to the other vertices. Wait for a while, it's not showing here yet. Okay, this one. So again, you can connect the two towns and then estimate the perpendicular bisector. For example, this one, do the same thing to the other points and then try to see their intersection. And that is the new Voronoi diagram. Okay, I'll give you maybe a few minutes, 3 to 4 minutes, to create the new Voronoi diagram and paste it here. So we are doing part 3 before we do part 2. All right, 3 to 4 minutes, begin. So I'd like to see the works of other students, not just the same person. So Phoebe is done. No, Samantha is done. The other one who presented the solution here again, sorry. Who was the one who gave the solution? Is it still Sam? Yeah. So I'd like either Phoebe, Kenneth, Jovita, or Joel to give their answers here. So maybe two students will give your answers, your drawing here. Again, it doesn't have to be accurate. Just estimate how the new one looks like. All right, begin. This one is given by who? Yeah, Phoebe. Okay, very good. So again, you don't have to create it, how do you call this one, accurately. All we have to do is just to somehow create a visual representation. So maybe when you take the IB exam, you can bring pencils if it's allowed. I think it is. So you can just draw the line and then somehow estimate the, um, let's say, the perpendicular bisector. This is actually how it looks like in the marking scheme. However, when you do answer, you don't have to give it accurately. You can just simply estimate. Okay. So if you try to look at it, if we connect this two perpendicular bisectors somehow meet here on the right side, but because it's outside the boundaries of the towns, so we don't include it anymore. Okay. So somehow it looks like this. Do you have any questions on this or clarifications perhaps? Yeah. So this one is correct already. You might be asking, sir, why are we doing part 3 first? Because we're doing part 3 simply because we wanted to visualize where the other two vertices are. By the way, before I proceed, I just would like to make it clear because I forgot to emphasize a while ago that it is stated in the problem that we're using actually the positive x and the positive y coordinates. So basically, this part here, because in my case, on my screen, it's not showing, sorry. This part here, class, is actually, this is the x, this is the x1, the x-axis, okay? And this one is the y-axis here, the positive x and the positive y-axis, all right? So you might be confused, you might be thinking that this one is the Cartesian plane. No, it's not. This is not the Cartesian plane. Okay, this one is the Cartesian plane, the y and the x. And then just to make it clear, this one, let me just use blue because it's not yet showing on my other gadget. So this one is actually the Voronoi diagram. Okay, this one here. All right. Okay. So if you try to look at it, this, for example, is the perpendicular bisector of E and H. This, for example, is the perpendicular bisector of I and E. All right, and so on and so forth. So basically, this one is the Voronoi diagram. Now, why am I asking that? You might be confused. You might think of it as the x and the y. We need that to find out this one, to find out this 20, 37.5. So if you try to look at it, Joel, can you mark where 20, comma 37.5 is located? Yeah, very good. Excellent. So we now have this 20, comma 37.5. So the other two vertices that we are looking for will be this vertex here and this vertex here. Do you follow? Is it clear? It's something that we cannot understand unless we see the figure. That is why I said we can do number 3 first before we do number 2. This time, I'd like you to, I'll give you some time to work out number 2. But before you work out number 2, I'll give you some clues. So if you try to look at this for the second one, for this particular point here, do we know the value of one of its coordinate? Try to see. Yes, we know. And if you try to look at it, we know which coordinate, x or y. X. And what is the x coordinate here? Very good, 20. Okay? We just have to find out the y coordinate. Why is it 20? Because this one is the midpoint between H and G. Similarly, we also know little information about this point here. And what info do we know about this point here? We, yep, correct. And we also know it's which coordinate? 20 is what? Which coordinate is 20? Y coordinate. So we can have it as blank, comma, 20. Okay, this one. Sorry, I'm using my laptop right now. So if we know an equation, like say the equation of this line, for example, we just have to plug in y equal to 20, and then we can find already the x, similar to this. So you don't have to do the longer process. You don't have to do the process we had a while ago. Since we know the value of one of its coordinates, all we need to know is to know one of the lines, and then solve for its x or solve for its y, depending on what is unknown. So I'll give you a few minutes to work it out. Kenneth and Jovita, I'll ask you to do one each. So find the vertex. Let's have Kenneth. Kenneth, I'd like you to do this one. The vertex wherein y is equal to 20, and Jovita, the vertex wherein x is equal to 20. For the other three, you could continue working it out still so that you can practice and try to compare it to the answer of Kenneth and Jovita later on. Okay? Perhaps I'll give you 3 to 5 minutes to work it out. Ready? And begin. Yeah. This one is for, uh, this is Kenneth, right? Please confirm. Yeah. Okay. Yeah. By the way, Kenneth, since we're doing Math AIHL, what you're doing is actually correct, but you don't have to provide the entire solution. so that we can save time. Do you have any idea on how to solve this using numeric solver? Yeah, this one is already enough. Very good already. The moment you can show this, do you follow? Why were you able to get this, by the way? Can you share with us why were you able to get this? Yeah, 20 equals 3 half x plus 15 over 2. How were you able to establish this equation? It's given that what? Very good. Y is equal to 20, and this y equal to 20 lies on this line. Can you see the one I'm pointing right now? And this line happens to be the perpendicular bisector of IE, which was given a while ago. The equation was 3 half x plus 15 over 2. So if this point is a solution to this perpendicular bisector, then we can substitute the y to it and solve for the x. Is it clear? Yeah, so once you have established this, you can now say using GDC or using numeric solver or GDC, for example. So let's try to see if we'll get the same answer. So if we'll try to do GDC here, sorry. So we have 20, correct? And then that was, let's use math. Sorry. Okay, we have 3 over 2 of x plus 15, sorry. So 3 over 2 of x, and then you have plus, math again, 15 over 2. Okay, you could already use the numeric solver here. How do you solve it? You're going to press what? Just check. In my case, I just use graph. Press on graph. So you'll get 8.3333 and so on and so forth. So I'm not pretty sure how to convert this here in the numeric solver. If you know how to convert it, that's a lot better. But what I usually do if I see this one and if I see a long fraction, I'll try to, sorry. What I usually do is I'll try to type it in here, math, and then fraction, 8 point, I don't know if this is not, let me check. Go to 8.333333, for example, and then math, then fraction. Yeah, 25 over 3. So if you try to look at it. So I think we will get the same answer, 25 over 3. So that's the value of the x. So again, reminding you, you don't have to provide this one because we need more time. Math AIHL allows you to use calculators. So you can just say GDC or numeric solver and you'll get the value of the x. So this is now the answer. Is it clear? Yeah, please maximize the use of your calculator. Okay, how about for this one? Is this Jovita's? Jovita, can you confirm if this is your answer? But you're not pretty sure about it? Yeah, it's okay, no problem. That's the reason why we're doing this one. All right. What's the plan? Can you share with us what your plan, Jovita, or how you work this out here? Mm-hmm. Mm-hmm. Ah, okay. I see. I see now what you're doing. So you're using IE, right? IE happens to be this. Can you see my cursor? Yeah. But the point we're solving is this point. correct? So the question is this point a solution apart or found on the line IE? On the perpendicular bisector of IE rather, sorry. I repeat, is this point, the vertex that we're solving, is it found on the perpendicular bisector of IE, which happens to be this? Is it found, yes or no? No, it isn't, right? So, we cannot do the same thing. Do you follow? So what we can do here is to find either the equation of this line or the equation of this perpendicular bisector or the equation of this bisector, because this point lies on either one of them. Do you get it? Yeah. So we have to find this and we have to find this as well. Question is this given or do we need to solve for it first? Yes, because what we know right now is only the bisector of IF and the bisector of IE, correct? Yeah. So we don't know the bisector of IG or IH. So let's try to do the bisector of IG. Okay? So again, to find the bisector of IG, the equation, first we need to find the midpoint. The midpoint is the point located on this line. I hope by now it's pretty clear already where we're finding the midpoint. Do you all copy? Take two. Let me just write it here. What we wanted to find is, oh wait, let me just move it. Okay, let me write. Okay, we wanted to find the perpendicular bisector of IG, the equation of that line. Do you all follow? Yeah. So first up, we need to find a point on IG. And if you try to look at it, if we try to draw the, sorry, let me use a yellow one. If we try to connect IG, for example, okay, this is just an estimate, so don't worry about it. So IG, sorry, this line here, the blue line here, which is part of the Voronoi diagram, happens to be the perpendicular bisector of IG. Being it a perpendicular bisector, this point, which is also found on the blue line, is the midpoint of IG because it's a bisector. So this must be located at the middle of IG. So first we need to find the midpoint of IG. And the midpoint will just be equal to, you have 30, please correct me if I'm wrong, plus 40 over 2, and 20 plus 0 over 2, which gives you 35, 10. Is this correct? Again, please check. I might commit a mistake. And then please confirm as well so that I would know if we are to proceed or not. Sir, where did you get 30 and where did you get 40? It's the x-coordinates of I and g. We added them, divided by 2, and also the y-coordinates of I and g. Is this clear so far? Okay, we now have a point. We need a gradient. So we need to find the gradient of IG. So the gradient of IG is m equal to, we have here 20 minus 0, 30 minus 40, which gives us negative 2. But this is not the gradient that we want. What we wanted is the gradient of the perpendicular bisector. So we can say the m of the perpendicular bisector is just equal to 1/2. Okay, stop. Please try to look at it first. Let me change the color here so that you won't be confused. Okay, let me change this to blue. Is this clear so far? Yeah. So once we have this, we can now establish the point. If you remember, we have y minus y sub 1 is 10 equal to half of, we have x minus 35. Okay? Again, we are solving for the y, correct? Because we are given the x. So we are solving for the y coordinate. Now, since this one, we don't have to continue, by the way. Don't continue. You will be wasting time and you might commit a mistake along the way. Be wise. You're allowed to use a calculator. So you can maximize the use of your calculator. Even if I won't finish this will already somehow tell us the equation of this perpendicular bisector, right? Is it correct? This equation here is already telling us the partial equation of this. That's the unsimplified one. But we are not looking for the simplified equation. That's not our goal. Our goal is to find the y coordinate of this x coordinate. So this is already enough to us. Okay? So given this, we can now substitute the x coordinate and solve for the y. But we will not do it manually. We will do it using numeric solver. So to continue, so this is now the right equation, Jovita, that by which we are to substitute the 20. So we can now have y minus 10 equal to half of 20 minus 35. And from here, using GDC, which is numeric solver, can you do this in your calculator, please, and tell me the value of the y? Sir, is it okay if I continue and simplify it? It's your choice. Okay, no problem. So please work it out. So anyone using numeric solver, what have you gotten? What's the value of y? Exactly, very good, 2.5. So you don't have to provide the entire solution. It will take you a lot of time. Use your calculator, maximize its use rather. Therefore, the two vertices are from Kenneth's work 25 over 3, comma 20. And from this one, we can now have, what's the x coordinate? 20, comma 2.5. Okay, and these are the answers. Clear? Yeah. All right. So what I'd like you to do, let's have a 5-minute break first. So maybe if you want, you can. I know you might be copying or you might just be recording this. I'd like you to understand the first half of our discussion so that when we proceed to the next half, it will be a little clear for you. All right. So 5 minutes. We'll resume at 10:30. All right. Then we'll proceed to the last set of questions. Any clarification before we have some break? Yeah. So let's have a few break first. All right, let's resume. Just to confirm, can you see my screen still? Yeah, okay. Wait for a while. Let me just try to enlarge this one. Okay. Let's now head on to the next question. By the way, before we proceed, I haven't discussed this because it was only Phoebe who entered at first. The difference between paper one, paper two, and paper three is all of them tackles the concepts. For paper three, you only have two situations. It's the same as paper two. The only thing is, for paper three, you only have two situations wherein each situation is connected to different a lot more different conditions or situations. There are different branches of additional questions. Same with paper two, because in paper two, for one item, you have additional questions within that item. Paper three is the same as that, only that paper three is more situational, and each situation may branch out to a different question that may tap on a different topic or a different concept as well. But it's just the same process. So what you're going to do here is just to be familiar with how paper three is done, all right? And after you are familiar with it, hopefully, when you take the exam, the skill more or less might be quite similar. So at least you know already how to, um, let's say, manage, or you would be able to have some sort of a way to manage the questions. Okay? Similar to what I told Phoebe early on, you don't have to perfect everything. You don't have to get a perfect score. Although getting a perfect score will give you a chance, will give you a high tendency of achieving your target level. So this is what I saw. I've shown the class early on. Can you all see my screen right now? This is as per IB, the grade boundaries. So in 1 hour, you may not be able to finish all questions in paper three. And that's actually understandable because you are not required to get a perfect score to get a 7, for example. To get a 7, you only need 62%. This is as per IB. This may not, I'm not sure if this is updated. Hopefully it is. This is taken 2021. So if we get 62% of 55, for example, you're only asked to get at least 35 marks to get a 7. 35 out of 55 marks. In other words, if you won't be able to finish everything in 1 hour, you don't have to worry for as long as you're able to achieve the number or the amount of marks equal that of your target. Okay? Example, Joel, for instance, what's your target level? 5. 5 or 6. Ken, what's your target level, Ken? Kenneth? 4. So let's say 4. That's 19% as per IB. So 0.19 of 55, that's only 11 points, Ken, out of 55. For Joel, let's say 33%, that's 19 points, Joel, out of 55. So what's the point? I'm not telling you to really focus on that. If you can get more than that, that's a lot better. But what I'm telling you is you don't have to finish the entire paper. So you don't have to worry if you're not able to finish. For as long as you're able to get the minimum number of marks you need to get or to achieve your target level. Do you follow? So it's not about finishing the paper. It's about getting enough marks equivalent to your target level. Is it clear? Yeah. So be clear on what your target level is and then set your goal on achieving the minimum marks for that target level. Okay? If you can achieve more than that, that's a lot better. Okay? So let's now continue on our the next set of questions. All right. So I'll give you time to read on D. before I start discussing. Okay. Can somebody tell me what the situation in letter D is? You don't have to give me the exact one, but what have you understood about the situation? Anyone? Can I go back to Sam? Okay. How about Joel? The origin. From the origin, yeah. Okay. Thank you so much, Joel. Can you see my markings? Wait, that's wait. Can you see my markings? Yeah. I'll show you that the route or the how do you call this one? The where the car is passing through. Okay, it starts from 0, 0 as per the problem, and it travels to what direction? It travels due north before it heads west. It heads to the east. Correct. So it travels to the north. Look at the direction of what I am tracing. This is where the car is heading to. Do you follow? Now, before it heads to the east direction, it I mean like when it heads to the east direction, it passes through which towns or which places it passes through? E, E first, then I, then what? Then F. Do you follow? So if you try to look at it, if I'll stop here, for example, and from here if I head to the east, first I am passing by E. Get it? Can you see the green line? I am passing by E, then this time I am passing by I. And if I continue at this rate, will I pass by F? No, I won't, right? Therefore, for me to do that, the person has to travel further where? For me to pass by F. The person has to travel further to the north. Do you get it? So I'm just estimating. So if I stop here, okay, then from here I go to the east. I travel E. Do you follow? I travel I, then I pass by F. Do you get it? So somehow we can estimate that this is the route taken by the person. All right. So this it's very important for you to be able to visualize and to understand the situation because only then you can actually solve it. Okay. So before I proceed, do you have any questions? In other words, it cannot be anywhere lower than the yellow one. Because if it's lower than the yellow one, then it will not pass through town F. Get it? It must be higher than the yellow one. So this might not be exact, but this is just a representation of way a representation of the route taken by the person, meaning where the person passes through. Okay? Now, in the situation, we are told that the person starts from O and then no, from H, then travels north. Do we have any information regarding that? Is he traveling at a constant speed or at an increasing speed from the starting position to the north? Is it stated in the problem that the due north travel is constant? Try to try to read again. The due north. I'm talking about due north. Yes, the constant speed starts when he traveled to the east. Do you follow? So for the due north, we don't know any information for this. No info. But for the due east, this one, this is where he travels with a constant speed. Do you get it? Now, question is, when he starts traveling due east, what do you think is the distance? How far did he travel? Very good. It's actually 40 kilometers. Why do you think it's 40? Exactly. The point here, if you try to look at it, the point here from the origin going to point G is actually 40, meaning this and this should also be 40 kilometers. Do you follow? So this one is 40 kilometers. All right. So if you try to read further, what we are supposed to find here is actually the distance between G and the car's destination point. In other words, this is what we are actually trying to find out. So how long is this? And it refers to the vertical distance, the distance that the car traveled due north from H before he went due east. All right. Before I proceed, is it clear so far? Is it clear? Please give a feedback. Okay. So if you try to trace it out, we just need to find the vertical distance here. All right. So we have to find a way in order to solve for that vertical distance. Okay. I'll give you a few minutes, maybe 1 or 2 minutes. Try to find some information. Try to find a way here on how we can solve for the y coordinate or the distance, the vertical distance, before I give you an idea on how to do it. So try to find out first and give a suggestion. If you cannot do it, it's fine, but try your best to find a way first. So given this information, given these visuals, how can we possibly find for the vertical distance? Okay? I'll give you 3 minutes to think about it. Begin. All right. Can you possibly suggest a way on how we can solve this? Anyone? No one? But can you still hear me? Okay. So if you try to look at it, there's no way for us to solve this one using this one here or this line here, because we don't have sufficient information. So we need to find another source by which we could still represent the same distance but with sufficient information. So if you try to look at my drawing here, okay, since the car passes through um, all the other towns horizontally, therefore this must be horizontal as well. In other words, the distance, the y coordinate of these points and this point must be equal to that of this. Do you follow? The y coordinate. So we're looking, in other words, we're looking for the y coordinate of this point, and that must be equal to the y coordinate of this point as well. Okay, let's just name it as y, and this one is y also. But then their x coordinates are different. All right. First and foremost, this particular point is found on which perpendicular bisector? On the perpendicular bisector of IE. Do we have that equation? So what's the equation? Three over two x 15/2. In other words, we can actually solve for this distance, the y, if we know the corresponding x value. Do you follow? If we know this x value here, we can just substitute it here and find the y value. That y value is corresponding to the vertical distance traveled by the car. Were you able to understand it? Take two. Yeah, take two. So this point, okay, if you try to look at it, at this point, that's the y coordinate of this point is actually equal to this distance here because it's horizontal. So meaning all the y coordinates of the points found on this horizontal line must all be equal. Were you able to get that? All the y coordinates of all the points on this line. So this distance, this vertical distance is equal to this vertical distance, which is also equal to this vertical distance, which is equal to this vertical distance, the one we're looking for. Is it clear? So this point happens to be found on this perpendicular bisector. And we know that this perpendicular bisector is given by this equation, y equal to 3/2 x plus 15/2. All right? So what's the point? The point is, if we just know the x coordinate of this point, we can actually substitute that x coordinate to this equation. And by doing that, we can already solve this y distance, this y value, which is simply the distance, the vertical distance rather. Is it clear? If we only know the x coordinate or the x value, the corresponding x coordinate. But do we know? Yes or no? We do not know, right? It's unknown to us. So what we can do here is just to simply substitute it and assume it as x sub 1. So this would now be y equal to 3 halves of that x coordinate plus 15 over 2. Is it clear? All right. Correspondingly, if we know the x coordinate of this point, which we do not know, and this x coordinate is different from the x sub 1 because look at it, their locations are different, but the y coordinates are the same because they are just found on the horizontal line. If we only know the x coordinate of this point here, then we can actually solve for the y already. And that y represents the vertical distance that we're looking for. But since we do not know that, it will be the same situation as the previous. So what I can do is I can just write it as y equal to 3 halves of x sub 2 plus 15 over 2. All right. So here we have two things. We were able to create two equations here by which we can use in order to solve for the vertical distance. And the vertical distance is simply your y. All right, stop for a while, try to understand, and then ask questions if you have confusions. Can I proceed? Or do you have questions? Please give me a feedback if we can proceed, or if you have questions that needs clarification. Yep. Yeah. Sorry. Sorry. Thank you for that. Thank you for telling me. By the way, sorry. X sub 2, by the way, is found on this perpendicular bisector, not on this one. Do you follow? Sorry for that, Sam. So you need to use the equation of this perpendicular bisector for x sub 2. Can you give me the equation of the perpendicular bisector for that? Negative, what was that again? I know this. 1 over 2x, and this is 95 over 2, right? Sorry. So therefore, that must be y equal to negative 1 over 2 x sub 2, sorry. X sub 2, all right? Then you have plus 95 over 2. Okay, this one. All right. Thank you, Sam. Any other questions or clarifications? None. Okay, let's now proceed. So what we can do here, class, is simply to connect both and eventually to solve for the y. All right? So we just have to connect both of them. So is there a way for us to connect x sub 1 and x sub 2? So that only y remains, because we have to solve for the y here. So we should not eliminate the y. We have to eliminate x sub 2 and x sub 1. All right? So we need to connect them so that it should be like this. X sub 2, x sub 1. Whether we add, we subtract, we multiply, we divide, it's up to whatever is okay, equal to a certain expression here with the y, so that we can solve for the value of the y. So let's try to find a way on how we can connect. We can find a value for x sub 2 and x sub 1. So look at this one again. Look at this figure again, this one. Is there a way for us to find a value of x sub 2, x sub 1, or connect x sub 2 and x sub 1? Is there a way? There is one statement, the last part. It says, can you find that statement? Before 30%, yeah, 30% of the travel time is spent in town I, which is this one. Now, since this is a constant speed, it only means that the person traveled with, or the person covered the same distance per minute. So the person spent the same distance. It doesn't mean that here he goes faster, here he goes slower, here he goes faster. No, the speed is constant. In other words, it's the same all throughout within this particular distance here. So it's the same as spending 30% of the time here. It's the same as covering 30% of the distance as well. Do you follow? So 30% of 40 kilometers is spent here. All right? In other words, the distance between the distance here will just be 30% of 40. So we can actually do this because it's the car traveled with a constant speed. In other words, as what I've said, it's constant all throughout. So there's no town by which the car traveled faster. So traveling faster means covering a shorter time. And there's no town where the car traveled slower. All throughout the journey going to the east, it's a constant speed. So we can safely assume that 30% of the total distance has been covered here. All right? And 30% of 40 is equal to 12 kilometers. So this must be 12 kilometers then. Okay? However, we need to come up with an equation that shows x sub 1 and x sub 2. So how can we make use of x sub 1 and x sub 2 and then 12 kilometers? Or how do we find this distance here using x sub 1 and x sub 2? Well, let me give you an example for you to visualize. What if x sub 2 is 30? X sub 1 is, let's say, 12. How far is x sub 1 and x sub 2? Very good, 18. How do you solve for 18? 30 minus 12, very good. This distance is 18. In other words, if we know that this is 12 kilometers, so we can just say that 12 kilometers, let me erase this part here. Let's just say 12 kilometers is equal to what? This one, this distance is equal to, just like 18 here, 12 is equal to x sub 2 minus x sub 1, because 2 is farther than 1. So this is now the equation that we can get. Do you follow? Okay. In other words, if we can put it in here, then we could already solve the equation. Okay? We just have to make sure to get an x sub 2 minus x sub 1 later on. All right? So, sir, how do we solve it? One way of solving it is to express this one as x sub 1 and to express this one as x sub 2. So it must be x sub 1 equal to something and x sub 2 equal to something as well. Then we subtract and then we equate it to 12. All right? Can you try it out on your seats first? Solve for the y value. Okay, I'll give you time to solve it before I'll show you the answer, or before I'll show you the way on how to solve this one. So maybe 5 minutes, begin. And then once you're done, you can tell me what the expression for the x sub 1 and the x sub 2 is. So we can confirm. Okay, can anybody tell me what x sub 1 is equal to based from the one that we've got above? So x sub 1 is equal to, can you confirm? This is what I got. X sub 1 is equal to 3 halves y minus 5. No, not 3 halves, 2/3 rather, 2/3. 2/3 y minus 5. Can you check if it's correct? So we just did algebraic manipulation here. So what we can do is transfer 15 over 2 to the left. So y minus 15 over 2. And then multiply everything by 2, then divide by 3. Can you check if this is what you've got also? Ren, please confirm. Yep. Which one? No, x sub 1, we cannot solve it yet because what we can do here is just to manipulate this one. So from here, um, we can manipulate it so that we can have an expression for x sub 1. So we transfer 15 over 2 to the left side. So that's y minus 15 over 2 equal to 3 halves x sub 1. Do you follow? And then multiply both sides by 2. So this becomes 2y minus 15 equal to 3x sub 1. Divide both sides by 3. This now becomes x sub 1 equal to 2/3 y minus 5. That's it. So why are we doing this? We need to have an expression of x sub 1 and x sub 2 so that we can use this one. This part here, we can use this. So the expression of x sub 2 minus the expression of x sub 1 equal to 12. So we need to find the individual expressions first. How about for the others? Do you have a question? Clarifications? See. Next, can you give me, yeah, thank you so much, Joel. Can you give me now the expression for x sub 2? Can you confirm? I got negative 2y plus 95. Can you check? I might be wrong. Because we need to transfer 95 over 2. Or what you can do, you can multiply everything by 2 first before you do any transferring. So this becomes 2y equal to negative x plus 95. Is it 95 or 83? Okay. Oh, sorry. I see. How about for Phoebe, Sam, and Jovita? Questions? Yeah. So once we got this expression here, these expressions are just coming from the one on top. Then we can now create our final equation saying that x sub 2, this one, we continue this. X sub 2 minus x sub 1 is equal to 12. So negative 2y plus 95 minus, we have 2/3 y minus 5 equal to 12. All right. And if you try to look at it, we now have a single variable y, which is what we're looking for. Okay? Question, do we need to solve this manually? Yes, that's it. Maximize your calculator. So this time, we use GDC. Numeric solver, can you help me find the value of y using numeric solver? So what is y equal to then? Yeah, that's it. 33 kilometers. Don't forget to use the unit kilometers. Okay, and that's how to solve for letter D. So I think what's difficult in D is the analysis. That's why I encourage you to bring pens or pencils rather. Then you can do some tracing. So you trace, so that it's easier for you to visualize things and analyze things as well. Okay, so let's now proceed. By the way, do you have any questions before I proceed to the next? Yeah, let's proceed now to the next part. So the next part is now this one. Okay, all right, this one. And I think for this one, we need to have the picture again of the Voronoi diagram. As much as possible, if you can create a good picture illustration during your IB exam, that would be a lot better because you will be using it from time to time. There might be questions which makes use of it from time to time. Okay. So I'll give you a few minutes to look at this, read, and then try to understand what you are supposed to do here. Okay, so let's start. Here we have a toxic waste dump, which has to be located within the metropolitan area. So the entire space here is the metropolitan. So they wanted to put or to locate it as far as possible from the nearest town. Okay, so here we don't have a choice but to place the toxic dump to a town. To we have there will be a town that will be sacrificed, meaning the toxic dump will be placed to a town, or I mean like one of the towns will be nearer to the toxic dump compared to the other three, or to the nearest town rather. So the question here is, the council wants to put it as far as possible from the nearest town. All right, even if that is the nearest town, still they wanted to find a location where it is as far as possible. So for letter EI, you need to decide on the location of the toxic dump. Okay? So try to think about it first. How do we find, or what could be our possible choices for the location of the toxic dump? Okay? Try to find out locations here which could be as far as possible to the five towns. Or what's the best location within this diagram that could be farther or as far as possible from the five towns. Just to help you through it, if I'll put the toxic dump within each region, let's say this one, look at my cursor. Is this the possible location farther from all the five towns? No. This might be far from E, F, H, and G, but within this location, anywhere within this location, it's near to I. If I place it here, it's far from E, F, I, and G, but that's near to H. So what could be our possible choices? Within the lines here, try to check. Yes, it should be this one within the intersection. Because we are pretty sure that this intersection, as much as possible, say this intersection is made up from the, let's say, perpendicular bisector of H and E, right? Of H and G, of E and F. In other words, this vertex, the intersection is as much as possible of equal distance to all the points within that particular region. Okay? So we have this point, and this point. So we have three choices, but we need to make sure that we choose a location that is farther from the nearest town. So if I'll choose this point here, to which point should I compare this with? F and? Okay, so if I'll compare this with F and with I, so what method should I choose? How should I go about it? How do I find the distance? Using the distance formula. Very good. So if you remember, the distance formula will be, let's say, let's use the capital letter D. Wait, sorry, for example. Letter D distance is equal to the square root of, you have x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So can you try to explore on which vertex would be the farthest to all the points within that particular region? So I'll give you 5 minutes to explore it within yourself and try to determine the best possible location of the toxic dam. Begin. All right. Anyone who has found a way? The point between the EI and which let me name this as vertex A, vertex B, vertex C. So A, B, B. Do you all agree? So according to Jovita, this must be this one. Um, Actually, I have another strategy of solving this. Instead of using the distance formula, it's the same, but the strategy is different. So what I did here, just to share with you, is to create right triangles out from this. So when I say right triangles, from this vertex going to this point, if okay, let me just color it this one with blue, and then I'll connect this one and create a right triangle. So I'm looking for the hypotenuse. Do you follow? This one, the hypotenuse. And then if I create another one to the other side, this one will just be the same as this because the two distances are the same. This is 20, this is also 20, and this one is 2.5. Do you follow? Yeah. So if we solve for its distance, you will find out that this is about 20.16. Sorry, this is also 20.16. Do you get it? Yeah. And then for this one, if you try to look at it, the y coordinate here is 37.5. Try to look at your notes, the ones that we solved a while ago. If this is 37.5, that means that is the vertical distance. So this distance here will just be, if the entire vertical distance is 40, the entire thing is 40, and this is 37.5, therefore the remaining distance on top will just be 2.5 also. In other words, if I'll create a right triangle here to find the distance, this must be equal to this as well, 20.16. Is it clear so far? Okay. So we are now left to check on the other vertex. So for this vertex, the one that we have shaped, this one. So this is 20. And of course, the lower part, if we make a triangle, it's still the same thing. But this one is how long? The x coordinate. This is 25 over 3. So if we try to solve for the hypotenuse, so the distance is equal to square root of, we have here 20 squared plus 25 over 30 squared. This gives us 21.67 kilometers. Follow? So among all the vertices, this is the ideal vertex because this is the farthest as much as possible from the other points. This one is near, so as this one. So this is the only one that we can use. All right, so to choose the location should be 25 over 3, comma 20. This is where the toxic dump must be located. So you can use the distance formula if you'd like, but if you try to be wise enough, if you try to save time, you can create figures that will help you save much time. When I say create figures, the one that I created below mirrors the one on top, so I can save time. So I can just solve one of them and then solve the one on the side, and that will allow me to save as much time as I want. All right. Question, clarification, please. Yeah. Again, I'll remind you, you don't have to perfect paper 3. You just need to get enough score to achieve your level. Okay? So that should be your target. All right, let's now head to the last set of questions before we go for a lunch break. Okay, the last set of questions involves another set of concept, but I tell you, this one is not actually difficult. By the way, make one possible criticism. Sorry, there's still one question. Make one possible criticism of the council's choice of location. So even if this is farthest among all the points, what do you think could be um, what could be a reason, or what could be something that the council has miscalculated, or what did the council what sorry, how do I say it into words? What did, or what is that thing that the council failed to consider when choosing this point? Or what did they miss? They're only considering the distance. What could be a possible thing that they should also consider when choosing a location? They considered the distance because they wanted to consider the farthest possible from the nearest town. So the distance is checked. What could be something that is missed by the council? They were not able to consider the who will be affected. Let's say, who will be affected with a toxic dam? It's toxic. So if it's placed in a certain location, there will be after effects. And who will be affected by this? The population, the people. Do you follow? So this point here is somewhat nearer to a certain town. There's one town that is near to this location. Question: did they consider how many people are found in that town? No, that wasn't part of the condition, right? The nearest town could have more population than the other towns. Do you follow? And the more population, the more casualties there could be. So one thing that they failed to consider is the population of the nearest town. Because among all the points, the nearest town is the one that is being sacrificed. When I say being sacrificed, with all the right intentions, they wanted to place the toxic dump in a location far from all points. But there will be one town that will be relatively nearer compared to the other four. Say, for example, that will be point I. Did they consider how many people are in point I? Maybe point I is a progressive town. Because it's a progressive town, maybe in this country, in this metropolitan, more people are settling here. If that is the case, then a lot more casualties will be there as population grows. Do you follow? So part of their decision should be to consider as well how many people are found in the nearest town. It's not just the distance. Because what if E is far, but then there are only a few people here? So that should be one thing that they have to consider. All right. So let's proceed now to the last set of questions. This is now a question letter F. And this has not something to do with the Voronoi diagram. All right. I think we're now down to F. Yeah. F. Sorry. Let me just capture all the questions. How many of you here tried letter F? No one? Actually, this is the easiest among the questions we have because you don't have to refer to the Voronoi diagram for this. All you have to do is to play with matrices to understand what this one means. Okay? I'll give you 3 minutes to understand what this means. What is the 1? What's the meaning of the 1? What's the meaning of 0? By the way, these matrices refer or corresponds to the different um, towns and the location of the toxic dam. So T is the toxic dam. So if you try to look at it, if you try to understand it, We can refer to this as E. This is F. This is G, H, I. This is T. E, F, G, H, I, and T. Do you follow? So I will give you 3 minutes to understand what one means so that it's easy for you to understand my discussion. Begin. Sorry. Sorry. Okay, stop. Can you tell me what the one means? Whenever I see a one here, what does it mean? Anyone? Very good. Take note, we're talking about the sower. Okay? So it's not the town, but it's the sower. So deep beneath the road, maybe perhaps the sower between the towns are connected. So let's try to see if you were able to understand it. Can you tell me which sower is directly connected with town G? Oh, it's easy. Very good. So it's expected that G will be connected to itself because G to G is just the same sower. Do you follow? So G is connected to E and connected to I. Very good. So again, E is um, expected to be the same E. So this one is 1. It means it's connected because it's the same sower. F and F, it's 1. G and G, it's 1. That's why we call this the diagonal, the leading diagonal. All right? Do you follow? Yeah, okay. So the first question is, find which town is last to be polluted and justify your answer. To be honest with you, I don't like the answer given by the marking scheme. When I answered this, I didn't look at the marking scheme yet. So the solution in the marking scheme is actually okay, but then it doesn't give you the picture of what's happening. I mean, like you just have to input it and then that's it. I'd like you to understand what's happening. Where is the pollution coming from? Where is it coming from? Is it coming from town E, town F, town G? What's the source of the pollution? Yeah, very good. It's the toxic damp. That's the source of the pollution. Do you follow? And it travels through the connected sower for how many, for what time, for how long? How long does the pollution takes place? Or how long will it, 1 day? Do you follow? That means the other town's sower will be polluted for a time of 1 day. So if you try to look at it, if everything starts from the sower, sorry, from T, sorry, we need to find out the sewers connected, that of T. And we need to find out as well which sewer will be the last to be polluted. I will start it and I'd like you to continue and find it out. So I'll start with sewer T and then here also T. Can you give me the first sewer directly connected to T? Which sewer is connected to T? F. And also what? H. Very good. And it takes how many days to pollute F and H? 1 day. So in 1 day, both will be polluted. Do you follow? Both F and H will be polluted. Now after F, because F is now polluted, so it will travel to another connected sewer. So where will it travel to from F? Are you sure? Look at F. Look at F. What's the direct connection? We find a sewer that is directly connected to F. F and T only, but F cannot pollute itself. It's already polluted, right? And T is the source. So it ends on F. Do you follow? But then for H, is it connected? Yeah. Can you continue the H and determine which one is the last to be polluted? And then determine how many days will it take the last town to be polluted. You can, but when you take the exam, nobody will tell you to do that. So if you understood this using matrix, go on. But then if you wanted to really understand what's happening, if you interpret the meaning of one, you could also do that. So I'll give you the freedom to do whatever solution you'd like. Just to continue, Phoebe, the reason why I'm doing this, it's difficult for me to explain it using matrix because it doesn't make sense actually for me, just for me. I understand this one better, or I can explain this one better. Yeah, correct. That's correct. Yeah, that exactly. That's correct. So if you're able to understand the situation on that perspective, go ahead with it. That will make it, I think, faster. So for those who continued what I did, sorry, previously, what do you think will be next to H? It will be E. Let me check. Yeah, correct. E. E. So let me just write E here. And then that will be 1 day also, right? To do that. Correct? After E is polluted, what will be affected next? G. All right. G will be polluted. That will take 1 day as well. And then what's next to be polluted? I. And it will also take 1 day for I to be polluted. Okay? So if you try to look at it, we cannot continue anymore because we only have 6 locations. F has already been polluted after 1 day. Do you follow? So what do you think is the last town to be polluted? Yeah, I. And how many days did it take to pollute I? That's it. Done. Do you get it? Yeah, that's it. So this actually for me, it's not that difficult because I just need to understand the meaning of 1, 0 here. for me to be able to do the questions. All right. Questions, clarifications? And the last question would be easy if you understood this. All right. Before I proceed, please ask a question. Ask a clarification, please. Wait, let me just copy this again and also this one because we need this for the last question. Oh, sorry, not this one. Let me just copy this one, the one that I drew. So we need this one with the labels. Okay, so here for the last question, you have here a sower inspector. He plans on the shortest route through each connections between the different locations. So determine an appropriate start point and appropriate end point of the inspection route. So in this case, the inspector just wanted to plan out on how he can probably check on each route with the shortest possible route, shortest possible way. Okay? So here what we can do is we can list down how many connected routes are there for each location. For example, let's start with E. How many do we have for E? There are two, right? So for E, there are two routes. So this is the location and this is the number of route. Next, for F. How many locations for F? How many direct routes are there for F? Sorry. 1 for G. For H. For I. For the toxic dam. 2. So if you try to look at it, if you are the inspector, if you will start with E, you will be confused of whether to go to G or to go to H, right? So what could be a possible route that you will do first so that you won't be confused on where to go? So we can start with F, right? Because in F, there's only one route connected to it. If we start with E, if I'll go to G, I'm not pretty sure later on I'll pass by H. Do you follow? Take two. If I'll start with E, since E is connected with G and H, if I'll choose G, I'm not sure if H will be passed by through later on. Similarly, if I'll choose T, the source, if I'll start with F, I'm not sure if H will be passed by through later on as well. So better choose some sort of starting point where you only have one choice. All right? So you said here, we'll choose F. Is there only one possible starting point? I could also use I. So what if I'll choose F? So from F, I'll go to where? From T, I'll go where? From H, I'll go where? E. From E, where should I go next? G. And from G, where should I go next? I. And here, I'm now sure that all locations have been checked. All right? In other words, I can start with F and end with I. Or I could also do the other way around because all of these are connected, right? So I can start with I. So I'll just put two arrowheads here because they are just connected. So I can start with I and end with F. And that's how we answer the last question. Any questions? Okay, that's why I said the last question is not really that difficult to understand. So if you wanted to do this by matrix, it's fine. But I think Phoebe, you will not be able to use matrix in the last question. The last one. Yeah. So that's it. Any questions or clarifications? None. So I think we'll end here and then we'll continue at 1 p.m. Please attend 1 p.m.'s class because um, the 1 p.m. class will involve exponential and linear regression, and I'll have some tricks using calculator that will be that I'll be teaching you during that time. All right. Anyways, I will still record the meeting, so you can still refer to it though. But attending it, you will have a chance to ask me questions. Okay. Any other questions or clarifications? None. If there's no question, then I think